goal is to go through the Gaussian distribution, do some problems, some examples, then do the Rayleigh distribution, some examples, and hopefully we'll be ready to get in to some of the other distributions. One of them is the Maxwell-Boltzmann curve that has to do with actually gas dynamics. So this is the quiz. So for the quiz, I think I said that there's a random variable that's uniformly distributed from -1 to 1. So if this is x, it means the density function, f of x, is constant. Do y'all follow me in this class? This is literally the problem. I didn't change anything on this one. If you look in your books, it's problem 7. By the way, how many people did that problem before the quiz? I figured about everybody did it, but when is it dripping or not? When I give you problems, the quiz is based on one of these problems. It means it's one of these problems modified at worst. So please make sure you know how to do them, please. I can't give you more information. All right, now because just looking at it, the area under that curve has to be 1, right? If the width is 2, the height is, I don't think I'm going to talk more about that other than to say that's what uniform means, constant. Right? And if you did the problem, you know that. All right, after that I got f of x, then I have something I say y is equal to x squared, right? And that means x is square plus or minus square root of y. Do you all agree with that? Okay. Now, the first question was what? What's what?
The probability is the function of y.
So we want fy of y. Okay. And normally, and always, fy of y, this is the distribution function, is going to be the integral, right, of y of the density function. And the way I'm going to do this is, since I have f of x here, and he does it this way, I'm going to say if I want to know what the probability of y is between certain bounds, I just have to figure the probability of x between the bounds associated with y, right? The functional formula. So this goes from what? Minus the square root of y to plus the square root of y, right? Of f of x, which is just 1/2, right? And it's dx. Now, does everybody agree with that? Correct? But even before you just go through there, I mean, evaluate if you can, but just look at this. If we have y equal to x squared, and this is x, and y has to have a value from 0 to 1 as its possible values because x has from -1 to 1. Do you all agree with this, class? I'm trying to make a point here. If that's the case, when I look at the probability of x being between minus the square root and plus the square root of y, right? In here, it's really going to be twice the probability of x being from 0 to square root of y. Do you all agree with that? So now what I'm going to do, I could put this down, but really I can say it just goes from 0 and put a 2 here. The only reason I'm doing this is to show you how I think about these problems. I try to, as best I can, to make them the simplest possible math for the minimal number of steps. That's the only thing I did. You can do it the other way, but I'm just doing this. It gets rid of the 2 is my point, right? So that equals 1. Y to the 1/2 power. Correct, class? Now we take a derivative. Take a derivative fy of y with respect to y, now I get fy of y here, and that's going to be 1/2, right? Y to the -1/2. Y'all follow me in that order? I think almost everybody that got this right put 2 over the square root of 2, which is absolutely correct. Do you agree with this, class? I think didn't you do it with the upper and lower boundary? You did the integral and then took the derivative?
Yeah, I used the CDF for the uniform, and then found f of y, and then took the derivative.
You did the derivative.
Yeah.
All right, now, something about this. You remember how in the book, if I had square root minus the square root of y, plus the square root of y and 1/2, we could have done what? We could evaluate the function at the upper limit, which would be square root of y, then take a derivative of that. You all follow me in this class? And then take the derivative of the top one, multiply, and then subtract the lower limit and the derivative of the lower limit. The value of the function f of x, evaluated x equals minus the square root of y, which is just 1/2, times the derivative of the minus the square root of y. It comes out the same way, either way. You remember how we did them at first, some of these problems, when we had f of x that wasn't a constant? And expect another problem similar to this, where f of x will be a functional form that may vary, it may not be a constant. I thought this was the easiest possible one. All right, now, so that's f of y. What's the next part? Anyone?
What is the mean value for cat y?
All right, now, I'm going to say this. If you look at the mean value of y, right, isn't that also the mean squared value of x? Do you agree with that, everyone? Remember that. Now, you can go ahead and take, and your calculators, I know, whip these things out. You can take y times this density function, correct? And then integrate it from 0 to 1, correct, class? And you will get the right answer, and I'll put it right here. So I could say that y bar, or capital Y bar, capital Y bar is actually equal to the integral from 0 to 1 of y times, and this is going to be 1/2 1 over the square root of y dy. And you can, this isn't a bad integral, but look at this. It's just 1/2, right? This is going to be 1/2 from 0. 1/2 from 0 to 1, and then it's going to be y square root of y to the 1/2 power dy. Does everybody agree with that? And then when you do the integral on this one, and I think you guys use your calculators, you would have 1/2, and the integral of that is going to be 1 over 1 plus 1/2. This is the integral of that. Then it's going to be y, right, to the 3/2 power here, evaluated from 0 to 1. And that's going to be equal to 1/2 times 1 over, and this is going to be 3/2 here. So it should be 1/3, I believe. Is that right? Pardon me?
Yep.
All right, another way to do it, and I'm going to do it this way because I kind of like this way. If I look at x squared, or I want the mean value of x squared, I can say y bar here is x squared bar. Now, maybe this isn't that useful right now to you guys because your calculators kind of do just about any of these integrals fairly easily. But to me, and especially with more complicated problems, this might be useful when we do integrations in both x and y, 2 dimensions. So just keep this in the back of your mind. So this is going to be the integral of the density function, which is 1/2, going from -1 to 1. This is the range where x exists. And then x squared times f of x, which is just 1/2, correct, class? dx. Now, if you look at that right there, that's an even function. If that's an even function, what I'm going to do is this. An even function integrated from -a to +a is just twice the value of the even function evaluated from 0 to a. So I just get rid of this 1/2, I make that 0. And now that is going to be 1/3 x cubed from 0 to 1, or 1/3. Either way will get you, I just think that way's easier. I mean, if you don't have a calculator, if you get in these complicated integrals that your calculators can't solve, just think along those lines. Try to make it the easiest possible integration. Oh, what's the next part?
What is the mean square value of y?
All right. How do you, obviously, what would you do? Over here, instead of y, you could put y squared, right? How many did it that way? It'll get you the right answer, right? What do you think I'm going to do? Sure, I'm going to do this because maybe I'm lazy. and old. And before the advent of these modern calculators and all symbolic integration, we always looked for a shortcut to do integrations. And I think a lot of your professors will still feel that way, even the younger ones. So if you come here, I look at this, and so if I want y squared, the mean value, it's really x to the fourth mean value. I hope you follow me. Agree? So this is going to be what? Well, when I look at this, that means y squared, mean squared value, or x to the fourth, I thought this was a pretty cool problem, is equal to the integral technically from -1 to 1 of 1/2 the density function, and this would be times x to the fourth dx, or it's going to be 2 times 1/2 with the integral from 0 to 1 of x to the fourth dx. I'm just doing this to make sure you see it, right? So that's going to be x to the fifth over 5, or 1/5. You all agree with that? Agree with me on this, everyone? It wasn't meant to be tricky or anything, just straightforward problem. Either way, you can do it with multiply the density function by y, or just take x squared, x to the fourth. Either way will get you the right answer. What's the next one?
What is the probability of y is less than or equal to 0.5?
Okay, again, either way to do it. 0.5, so coming back to here, 0.5, y equals 0.5.
It is less than or equal to.
All right, so this would be the square root of, I need x, right? So I'm going to do it with x, f of x. So x is going to be plus or minus the square root of 0.5, right? Or 1 over square root of 2. Agreed, class? So here's 1 over the square root of 2. And this is minus 1 over the square root of 2. You can already see what I'm up to. I need this area, right? That area is twice this area, right? Did you agree, class? So I can say that probability of y, the random variable y, as such, being less than or equal to 1/2 is the same thing as the probability of random variable x being greater than -1 over the square root of 2, less than 1 over the square root of 2. And for that, now I'm just going to say, well, that's 2 times the density function, or just 1 times the integral. And really, it's not even the integral. It's 1 times this from here to here, which is just 1 over the square root of 2. Isn't it, class? Isn't that right? You all see that? Are you with me? And you can do this so many different ways. Well, I said 2 different ways are obvious. So you can do it either way. Now, the last part, did I ask another part or not? All right, I should have, but the other is, what would the first variance of this be? You got all the information. What would the variance be, class? Variance of y, not x. So if I wanted sigma y squared, and I'm making this for a point because the variance of x may be different. In fact, it is. It's related to the square of that. So what would that be? Well, the variance always is going to be y. Y squared bar, the mean squared value, minus the mean value of y squared. Y squared is 1/5, right? Minus, what's the mean value? 1/3 squared. So that's 1/5 minus 1/9. And 9 minus 5 is 4.
4 over 45.
And that doesn't have an easy number. I don't see a number that's easy, right? But y'all follow me on that, class? By the same token, what was the mean, or what would that's the variance, and the standard deviation is square root of that, correct? All right. So what's the mean value of x? Here's the trick. We just think about it logically. If I want the mean value of x, just look. What would I do? I would take x, right? X is an odd function. Integrate it from -1 to +1 where the constant density is. You all see this, class? So here's where you get in trouble. You'll try to in some way interpret, if I have X bar, or I have Y bar, I can get X bar. You can't, in a general sense. You have to make sure you do this right with the formulas, all right? Or you execute the theory right. That's the mean value of X would be 0. By looking, what is the mean squared value of X? We just did that, didn't we? Wasn't that the mean value of Y? Class? So we have that. You all with me? And therefore, what would the variance be of X? This, which is what? 1/3, correct, class? 1/3 minus 0. And because the mean is 0, anytime you have a mean 0, the variance is the actual mean squared value. It has to be. Okay, I'm done with that one. I just wanted to do it. I thought I put the solutions up, and I'm sorry I didn't. Because I think that was a fair problem, but it's just trying to make sure that you understand the basics we were talking about. Nothing tricky here. It was maybe, I don't know, sometimes I'm not sure where the confusion is. But I know you can get real confused in this stuff. Okay, so today we're going to go through, I didn't go through the Gaussian problems yet, did I? But I gave you the information I think you needed to do. How many took a look at these Gaussian, for the section 5, Gaussian problems? Very good. Now, you have your calculators have that cumulative distribution function. I, of course, use the error function because that's what I try to find a functional form that I know works on my calculator or my laptop, and just use that because it makes my life easy. You know how to use, hopefully, you all try that cumulative distribution function. Does anybody here not know how to use their calculators to get that? Anybody? All right. You're going to be required to know how to use that effectively, like the sine of pi or something like that. It should be that clear. Would be no problem. So let me do, I actually want to do an exercise in the book. I have a bunch of stuff and made notes about tricks and things you can get in trouble with. So this is section 2.5. I'm going to hand this to somebody in a second. Do. But I want to do some of these things that they didn't have the solutions for. They have the answers. And in the book, or in the notes that I provided, it's here. Can you do me a favor? This is exercise 251. Now I don't believe it's in the book, the PDF of the book I posted, but there's no solutions to this, just answers, and the answers aren't necessarily in order that the questions are asked. They're kind of random. So this is exercise 2-5. This is an exercise 2-5. Can you tell me?
Exercise 2-1.
2-5.1.
2-5. A Gaussian random variable has a mean value of 1 and a variance of 4.
Alright. Now variance is, now make sure, I try to get you guys to do this, put an X there. This variance is associated with the variable X. 4, alright, now right away I do this. That means the actual standard deviation is 2. I think the variance is 6.
No, exercise, not the.
What?
He was on the wrong.
Yeah.
Oh, it's not the homework problems, but in back of the chapter, this is the exercise. Go ahead.
Part A, find the probability that the random variable has a negative value.
Okay, now, I'm going to use the Q function. You can use your cumulative distribution, but I know my Q of X, right, or Q of U, is Q of U here, is actually going to go from U to infinity, and this is going to be 1 over, you don't need to write this down, but 2 pi. Here, the standard deviation is assumed 1, e to the minus, and it's going to be u squared over 2 du. Now, that u in my Q function, I'm going to put down what it represents from the mathematics that I'm familiar with. in terms of a function I can evaluate this. You can use your cumulative distribution function, and you can do the opposite of this thing. You can go from minus infinity to u, right? And find that value and take 1 minus that value to find q of u. But for this one, q of u is 1/2, and it's going to be called the complementary pair function of u over the square root of 2. This is just for me. If you want to use it, go ahead. This is quick for me to calculate. That's the reason I'm putting it. All right? So, in either case, and this is q, if you use the characteristic function, and this is your cumulative distribution function in your calculator. And so, and I'm going to make it of u, but then I'll put down the value. That's the integral from minus infinity to u of 1 over the square root of 2 pi e to the minus u squared over 2 du. And needless to say, this is a characteristic function. The characteristic function of u plus the q function of u equals 1. That has to be the case. You all with me? Now the variable u is something you have to always remember. You're using your calculators or tables, and I will provide tables if you want me to, so you can look it up. But remember, u itself is going to be the actual value of x that we're talking about finding the information about, the probability of x being less than or greater than n, okay? Then it's minus x bar, all right? That is the average value of x, if it is provided. And it's divided by sigma of x. That's not sigma squared of x. It's real important. Because if you look at this operation, I didn't put it down here, but usually it's like x minus x bar squared over 2 sigma squared in this, in the integration. The way this is formed, it uses x minus x bar over sigma x. So keep that in mind. You all with me? By the way, if you take that thing and put it in here, right here, you get the actual definition of the probability based on the Gaussian. So for ours, we want the probability it's negative, correct? So I'm going to get u associated with this. So this is part A or part 1. So for part 1, u would be x, which is 0. If it's negative, we need the value. What we want is find the probability, here's how I'm going to do it, of it being greater than 0. Once I have that, I can take 1 minus that probability to get the actual probability that's negative. If you have your calculators, I encourage you to try this problem and make sure you get the correct answer with your cumulative distribution function. Okay. So equals 0, that's, I'm sorry. For this one, it's going to be 0 minus the mean value, which is 1, over 2, so it's minus 1/2. Y'all with me? Now, does anybody have the ERFC function on the calculator? If not, I can get it here. So for me, what I'm going to do is now I'm going to find out my Q of U, which is 1/2 ERFC of U, which is minus 1/2. Then I have to divide that by square root of 2. So I'm going to get a value. Once I get this value, and this is really minus 1/2 here. Once I get that value, the answer to part A would be the probability of x less than or equal to 0 would be equal to 1 minus that probability, which is 1/2 ERFC of minus 1 over 2 square root of 2. Now, you can tell me what you get doing it with your way. It's the cumulative distribution function, so you don't have to take 1 minus yours. It's just going to be the value. Y'all with me? Please take a moment. If you don't understand what I'm telling you, please just let me know. Now I got to get this thing going. What's that? For what? That's the answer.
Wait, did you do?
You have to take the mean value and stuff and put it in. It's not, the mean value is not 0, it's 1. Hold on. I'll tell you what I don't know. He has the book.
The answer for
Yeah.
you. No, the answer's like 0.
Yeah, that's what I got.
hold on. All right, I'm gonna tell you what I did. I did these, I just don't remember the answer. This is good. Please make sure you know how to use your calculators. That's exactly what I want.
Did you get my answer?
Point
You're not
three
showing,
zero.
Yeah. you're not showing me what you put in.
I think maybe it means something about zeros.
Give me 1 second.
Zeros.
Okay. No, why'd you put one
Yeah, that's for me.
for you?
Yeah.
Is you.
That's your mean value.
We said it was negative 1/2, right?
No, the E is one. And it's given option.
I got 0.309. What's the answer?
That's what I got.
Extra? Okay. Now, I didn't use, I'm doing it my way. All right. Did anybody not get that answer? Did you get it back there? You got it? You got it? Can you show Blake? You have an Inspire? Make sure, I want to make sure everybody sees this, because you're going to have to enter the mean of your cumulative distribution function of the value of x, the mean, and I think the standard deviation. Make sure you don't enter the variance, standard deviation. These are the little mistakes that'll mess up everything.
So, just like a fair warning to everyone on 252 on the homework, the
Solutions are
three are
correct.
wrong.
We'll get there. Just a reminder, okay? Yeah, I think it is right. I remember doing these things. I did this set for Friday's class. But I know what you mean. This one is one of those I wanted to make sure I talk about. Is there any other part to this? Sure there is, right? So we got the first part. We got the probability that x is negative. What else do we need?
So, quick question. So it asked for u, is it mu or u? Mu.
In your calculators, the u, there or mu, is the average value. In your calculator.
The average value,
In mine and in the book, the u indicates the argument of the function.
which was that negative 1/2.
That's in the book uses the same symbol. So don't confuse yourself. In yours, that's the mean value. If you read your,
Okay.
what do you have, an Inspire?
Yes, sir.
Yeah. If I'm saying anything wrong, let me know, because I don't have one of those. I may have to get one just so I can keep up with the class. I got an ancient HP upstairs.
Yeah, that makes sense.
You got an HP, don't you?
Yeah.
I like HPs.
I do too.
But again, they call it reverse Polish notation, first in, last out. I feel if you
Yeah, I
use
have,
the
I have
stack
HP
memory.
50G, so
Huh?
I have 50G before I got this one.
But look, I'll let you. TI, I think, overtook the calculator industry because people didn't like that reverse Polish because it's based on the stack. When you do machine language programming, that's how you have to do it. And I think people have an animosity towards that. HP is a really good calculator. All right, next part.
The probability that the random variable has a value between 1 and 2.
Greater than 1, less than 2. Y'all agree with this? Now, you have your cumulative distribution function, so you could say the probability that it has a value greater than 2, right, minus the probability it has a value greater than 1. Do y'all agree with that, class? I'm going to do it my way. We'll see who gets the right answer of the vote. So what I'm going to do is first, I know that q of u is equal to the integral from u to infinity of, and I'll just put f of u here. I think everybody understands that. F of u du. So now I need u, and the mean value was 1, the standard deviation was 2, right? And now from 1 and 2, so now I need u, and this is going to be when x is going to be 2, so this is x equals 2. So that's going to be 2 minus 1 over 2, or in this case, it's going to be 1/2, or I'm sorry, yeah, 1/2. And then I need u of x equals 1, and that's going to be 1 minus 1, which is 0. So now, for this, like I'm going to do it, is take my q function of u equals 0, that's associated with x equals 1, and I'm gonna subtract, which is the opposite of what you're gonna do. Because I'm using the q function, and the q function, remember, starts the integration at u and goes to infinity. Your cumulative distribution function starts at minus infinity and goes to u. Are you with me on this? I'm not trying, Blake, are you with me on this or not?
Not really.
All right, what don't you understand so I can help you?
I'm just kind of all over the place right now. I don't know.
Go ahead.
I don't really know what's going on.
Did you do these problems?
No.
Okay. Did you know what the Gaussian distribution is?
Oh yeah, I do know that.
You know what the Q function is?
No.
Were you here Friday?
Yeah.
Do you remember me talking about this on Friday?
Yeah.
All right, well, I'm gonna do it just for you, real quick. When we have the Gaussian distribution, in general, it's 1 over the square root of 2 pi, and that's sigma, but it's a sigma associated with x, exp minus the quantity x minus x bar squared over 2 sigma x squared. That's the density function. The cumulative distribution function that you guys are doing, and this is the cumulative distribution function, is f, and then you're gonna have x, I think it's this way, you tell me if I'm wrong, u, but that u is not the u there, that's the mean value. So make a note, this is the mean value. And then it should have the variance of x, the next argument. You have to have 3 arguments.
Yeah.
You need your
Ours is
Or-
just the
Lower.
lower bound, then the upper bound, which is x, then our.
okay, so it doesn't do, so you gotta look, never mind.
Yeah, they're just.
Let me just put, no, I wanna put it right. So your cumulative distribution function is going to be f of, and f, and I'll put up x of lower bound first,
Yes.
x lower, comma, x upper,
Then mean, then
then the mean, and this is the mean value, and then
the standard deviation.
standard deviation of x. So it's 4 arguments, but you can default, I think, at the lower bound is minus
Yeah,
infinity.
it don't have to be the false, but you can change it.
All right? And then, so that is the integral of that function. I'm just going to leave it at f of x dx here. And that goes from x lower to x upper. It's perfect for these problems. If you do know how to use your calculators. Blake, do you follow me on this? All right, so literally you can just take your calculators. Do you know where your cumulative distribution function is?
Yeah.
You could literally, because this thing states everything you need. For this one, it's a no-brainer for you guys. So if you want this probability between x greater than 1, less than 2,
You just put, we have 1, 2,
1, 2,
1,
1, 2. Tell me what you get. I'm gonna
Wait, 1 time, 1 5.
That's what I
That's cheap, man. Did you get this, Blake? Make sure. I want to make sure you can get this. Because I tell you, you don't want to be left in the cold. I mean, you really got to keep up with this. If you don't know how to use a calculator, you say, how am I going to talk to you about Rayleigh and some of the other crap? You got it or not? Did you get it the right answer? Did you know how to do it?
On the calculator,
What do you have?
36X Pro.
What, that's the TI, right?
Yeah. I got the 89. I don't know if it's similar.
Well, doesn't that have the function on it?
Not that I know of.
It doesn't have a cumulative distribution function?
don't think so.
I don't think we would.
Or do you have an error function?
It's not a graphic.
Not that I know
Look, you need to know how to use it, because, you know, I'll give you tables if you want. You don't want tables.
of. Does anybody have the 84? I got the 89.
It's not actually.
The TI-84?
Yeah, I don't know if it's good though. But I have actually 84.
Look, I know it shouldn't take class time to do this, but I feel for people in this. If you get left behind in this, you got to understand, you're going to be so lost, you won't know where to turn. I'll give you the tables if you want, but kind of a pain.
Yeah, I was going to have a CDF from TI-84.
But is that plus E or just?
Oh, they got the NP.
It's like just the regular 84.
Okay, I have.
But this has got, no, wait a second. This has got statistical stuff. I'm sure you have a way to get the error function ways too. Please make sure you know how to use it. Because I hate assuming something and I'm so far lost. You're the only person, what kind of calculator do you have?
Okay, sure, but I don't have calculator.
Do they have an error, are you using a cumulative distribution or error function?
like I have a the mod name, the distribution.
All right, you know how to do it, right? You're getting the right answers?
So the 36 Pro.
Yeah, if that one can do it, then that one should be. Should.
What? Say again? What were you saying, sir? Colin, what were you saying?
Like I have like a normal CD, like it's still like
But it works, right?
It's work.
What did you say?
It looks like the 36X Pro should be able to do it.
That's the one you have?
Yeah.
I'm almost guaranteeing you it does. The problem is, if you don't spend time looking up how to do it, you're never gonna know. Because some of these things, you gotta hit 2 or 3 buttons sequentially in order to get the operation executed. And you have to know how to do this. All right, I'm gonna do it my way real quick, and this is the last time I'm gonna fuss with this. So, the only thing I need is, I got, what? Go ahead.
I found where to find out the 36.
Do you have one?
Yeah.
Can you come over here and show them? No, don't worry about it, just do that. I'm gonna do it my way, all right? So first, I gotta get this, and then I gotta get this. So I'm gonna use my error function, and I know now the probability, you tell me if I'm right, x less than 2, that's equal to 1/2, and it's the error function, so I'm just gonna do this way, it's ERFC of the upper bound, or the lower bound, which is 0, which is just 0, and that's 1/2, minus ERFC of 1/2 square root of 2. And let me tell you what I get. You tell me if I can get the same answer. I know it seems like a waste of time, but trust me, if I don't get you guys to do that and he's helping him, I know how much problems. It's gonna be 1/2 square root. Thank you. And this is gonna be ERFC of 0 minus ERFC of 1/2 square root. So I got 0.191. Is that what we did? Yeah. Okay. So I get the right answer, you guys get the right answer. And I'm doing it totally, I'm just using an error function, that complementary error, because I know every calculator in the past had either the error complementary error function on it, just because it was so, and I'm sure yours does too. Do you know how to do it now? All right, please keep up with these problems. What's the next part?
So sorry, the probability the range variable is greater than 4. Did we just do that one?
We didn't do that one, but what is that really?
4
For
row
me-
bound.
Yeah, you got your things, right? For me, I have to do what? X minus X bar over sigma X. So it's greater than 4, 4 minus 1 over 2. That's 3/2, right? So for me, I can go in there and I can say the probability that X is greater than 4 is just gonna be 1/2 ERFC of, and then it's gonna be 3/2 square root of 2. I'm gonna tell you what I get, you can tell me what you get. .067? Yeah. Is that what you guys get?
Yeah.
Roughly?
Yeah.
I'm rounding, okay. Is there another part?
That was it.
Okay, question? Back to this guy. How would you get the third central moment? What is x minus x bar cubed average value?
Maybe 0.
Why? You're right. Odd, right? Odd central moments always are 0. Now, I'm going to ask you a question like that. It may be the 5th, it may be the 9th. Y'all follow? Don't brute force it. That's what I'm trying to do. Because if you're like me, a lot of times, especially if I'm tired, I'll just do it with my calculator. You know, especially with some of the weird ones, you won't get the right answer. I mean, if you get higher level intervals, you can't solve it. Okay? There's another exercise. Can you do it real quick?
Yeah.
Okay. Did you get the right answer? No.
Oh, yeah, okay. I was trying to figure out how to do it on the H4 and I figured out.
All right.
Oh, just, I like to, just in case one goes down.
Yeah.
PI usually is fairly consistent with the formatting and everything.
On this calculator, you could do like, you could simulate dice rolls, you could simulate coin flips. Yeah, like a whole probability simulator. Yeah. You could like do cards.
Listen, the time's coming when you'll be able to talk to your calculators and it'll solve. I'm convinced with AI.
Yeah.
I see this Chat GPT stuff, and some of the crap, they've got 4 different AI tools that are, it's not Chat GPT, but they're all, well, one of these things will do just unbelievable with the problems it'll do. It'll do all these statistical problems, random problems, within a certain margin of error. I mean, there are things they can't quite do right, but they're pretty amazing. Go ahead.
So for random variable,
This is, hold it, this is 2-5.2, but it's an exercise, right?
yes,
Okay, go ahead. Random variable.
of exercise 2-5.1.
Go ahead. So let me just put this down. The mean value is 1, the standard deviation is 2, and,
Variance.
well, I mean, we could do that, yeah. But go ahead.
He wants the fourth central limit.
Ah. You know, it's a pain. In the book, they have a formula, right? But now what do we need? We need x minus x bar to the 4th power, right? The average value. Did you look this up in the book? It's a central one, right?
Yeah.
Now, here's how you can do it in your calculator. In my opinion, well, I didn't do that. I don't know if you can do it the way I think. I thought maybe you could. What you can, obviously, the formal integration for this one would be what? The integral from minus infinity to infinity. And here you have x minus x bar. Well, x bar is 1, right? It's the 4th power. And then it's going to be times exp to the minus x bar 1 squared over 2 times 4. And it would be that, and I have to divide that by square root of 2 pi sigma x, which is times 2 down here, dx. I don't know if your calculators can do this or not. Probably, I'm not sure though.
This should be 768.
I mean, can you do it though? Well, I'll show you how to do it, but I want to just see if your calculators, did you try this one?
I do.
Yeah, I use the formula.
Yeah, you can.
Yeah.
The formula is, it's fairly what? You have to take this and square it and get what? X squared, right? And it's going to be plus x bar squared. And then it's going to be minus 2x x bar. And you have to write it again. X squared plus x bar squared and minus 2x x bar squared. Now, after you do that, you can put the numbers in if you want. And if you do that, or you can, in the book, he has a formula for this, I think, and I think it's 6 terms, but I don't remember. Well, you can do this. This is 1, right? All right, and that's x bar is 1, so I'm trying to make life easy. That's 1. And that's 1. So now I have this, right? And then you can go ahead and start, it's this times, I'm just putting the values in, right? So if I go ahead and I multiply this up, x squared, so this is going to be x to the 4th, and then you can go ahead, pardon me? Were you saying something? Don't worry about it, you can tell me, don't worry about it. But what I'm going to do is I take this, multiply through it, I get x to the 4th plus x squared, and then, now that and that multiply, then I get minus 2x cubed. And then I got to take 1 through here, so it's plus x squared plus 1 minus 2x. And then I take this through there, so I get minus 2x cubed minus 2x, and then plus 4x squared. Pardon me? I mean, go ahead, you can talk if you want, but what I'm trying to tell you is this is how I would do it if I didn't have a formula in front of me. I put the values, if it's small values of x bar and sigma I mean x bar in there. And the reason is I think the math is easier. If I look at this, the highest power is x to the fourth. So right now I need x to the fourth, and obviously this is going to be the average value of this. The next for x cubed, I got minus 2x, sorry, I'll zap that out of here. Minus 2x cubed minus 2x cubed, so it's minus 4x cubed, right? Minus 4x cubed. And then I have what now? For x squared, I got x squared, 4x squared, and 4x squared, so that's 6x squared, correct? I can correct, kill that one. Plus 6x squared, and then I have this last one. I have x. I got minus 4x plus 1. You can see some symmetry here. If you crack it right down, right on that 6x. Sorry, on the right. At this point, you're going to see 4 on either side and 1, the coefficient in 1. When you do this, now I need this, right? Average value. Okay, what's that going to be? Well, let's start the back. The average value of 1 is?
1.
Y'all with me? So I get 1. Let's see if I get the right answer. Then I have minus 4x. Average value of x is 1, correct? You understand I'm taking the average value of all of those, right? And they're additive, so you can take the average value first, plus the second, plus the third. We did all the multiply. You all agree with that? And what next? 6 times x squared, which is what? It's going to be, that's the mean squared value of x, which is just what? Sigma squared plus x bar squared? Let me just do it this way. X squared bar. This is going to be sigma x squared plus x bar squared. That is 4, and that is 1, which is 5, correct? So this is going to be 5 times 6, which is 30. Then I have minus 4, and this is x cubed. Now, and that's the fourth central moment. How did you guys do that part?
I did the formula I have with
That's the same thing
Wait, this is the central moment.
Yeah.
I did.
I mean, for the non-central moment, it would be mu.
No, it's going to be, I know what you're doing. This is even, right? All odd central moments are 0, right? For the even central moments, you get 1 times 3 times, and really, then it's going to go to the highest power minus 1, so it would be whatever moment you want. I think it had m minus 1, and then it's going to be times sigma to the m, right?
Yeah.
I think they have that one. Yeah, you can do that. So that's going to be 1 times 3, 1, fourth central moment. And then it's going to be sigma is 2 to the 4th. So this is a fourth central moment, right?
Yeah.
So that should be 3 times 16 or 48, I think. Right? And then what did they answer?
That was in the next part B.
So what was 700? Wasn't that the fourth moment?
That's the non-central. The fourth non-central.
Yeah, that is. I mean, fourth not. It's just the fourth moment, right? So how would you get it?
Mu to the fourth plus 6 mu to the
That's the thing for it. Okay. Are you okay with that?
So this is what we just solved for was the central moment.
That's the central moment, right there. The fourth moment. See that? See how x minus x bar the fourth? That's the fourth central moment. The fourth moment would be x to the fourth, right? I'm curious if your thing could evaluate that. It probably did. And it got stuck.
We got 40.
All right, got 40. So what's the next one then?
The fourth moment.
All right, how would you do it?
We just do x to the fourth. or X bar, or X 4 bar.
The, u to the fourth plus six u squared, sigma squared plus three.
These, your formula in the book is what you're getting from, right? So everybody's thinking to themselves, I don't wanna have to do this. If I give you a problem like this, it would require central moment. And if I'm going to give you anything with the actual moment for an even or something, then I will give you the formula. The only reason I'm saying that is to try to really not spend time doing all this multiplying. There's probably a way to do it symbolically. I'm not gonna go there. All right, that was, we're gonna do 5-2 because in the back, let's do, that's the second, is there any?
There's two parts.
What
Third
else?
central moment and third
Just-
moment.
All right, what's the third central moment? Because it's down here. Is there, what's the next part?
Third moment.
And how do you get that?
Just do the third.
You could do it that way, right? But, yeah, actually, you could do it. That's probably the easiest way.
So,
What's that?
whatever you got u plus u sigma squared.
Where do you get this from?
That's the thing that you still do.
Is this in the book or not?
I watched YouTube video. And
There's actually statistical formulas for all this stuff. I don't know if they're in the back of this book or not, or your book. It might be in that new one, honestly.
I haven't read it.
Okay, all right, let me do this. I want to do the problem in the back of the book that got the wrong answer, 2-5.2, right? Want to do that one? The Gaussian problems are pretty straightforward. Our biggest problem with them is making sure you can consistently calculate to get the right answer, because if I just see something you put down and then you go to your calculators, it's either right or it's wrong. It's not like something I can figure out that you just scribbled a 2 where you meant a 3. Okay. So, so this is going to be, now these are problems, 2-5.2. Can you tell me what is
2-5.2.
the problem? Anyone?
It says for the galaxy of 2 dash 5.1 pi, the fourth central moment
All right, first, for 2-5.1, give me the information.
is sigma squared equals 16
Oh, sigma,
squared.
yeah, of x squared equals 16, sigma is 4, go ahead.
And then mean is
5, go ahead.
5. That's it.
Let's
I'm
go
the fourth central moment.
it's Gaussian, right?
Yeah.
Fourth central moment. So, expected value of x minus x bar, fourth power. Now, did you guys use the formula for fourth central moment? Because that would be 1, because it's an even one, right? So it's 1 times, in this case, 3, and that's going to be times sigma, and this is going to be to the fourth power, right? And the formula I'm using is 1 times 3 times, and then it's going to be m minus 1 times sigma of m if m is even, right? And that's going to be 3 times 4 to the 4th is 16 squared. What is that? Is it 256?
Or are you trying to do the 16 squared or?
No.
Sounds easy.
Yeah,
Is that the right answer in the book?
yes.
Pardon?
No, that's not the right answer in the book.
It has all different values, like, has a different
Yeah,
variance.
they,
It's probably math there.
no, I think they put like the variance as
Oh, all right.
It's like,
They can make mistakes. But y'all with me on this? What's the next part?
the fourth moment.
How do you get that?
I did u to the fourth plus 16 squared, sigma squared plus 3
But what are you really doing? You're coming here, right? And you're gonna say, if that to the fourth power is really gonna be what? X I'll just tell you why I'm doing this, because on the test or quiz, if I look at this, this is really gonna be x squared, right, plus x bar squared minus 2x bar, and it's multiplied by itself, x squared plus x bar squared, right, minus 2x bar. That's what I was just doing, right? Now, the reason I'm saying it, the fourth central moment is going to be the first thing that comes out when you do this multiply, right? I got x squared, x to the fourth, so I get the expected value of x to the fourth, right? You know what I mean? I mean, this is the answer I want, but this is the fourth central moment, which we have, right? So let me put this up. This is 768. So now I have the expected value of x squared is the first, or x to the fourth is the first term in here, is equal to 768. You use the formula if you have. Is that the formula? It's not in the book or in the book? I think there is one in the book, right? The fourth. So anyway, now it's going to be minus the expected value of all the other stuff, right?
It's on page 72.
And he's going to show you the one you're looking at. That's the sixth term one, isn't it?
3 terms.
Oh, okay. That's even better. So, I'll tell you what happens here. If you go, this is how I do it if I really got stuck in a jam. If you go ahead and take a look at this, I'm going to have x squared, x to the fourth. That's what I want the expected value of. Everything else, now that I pull that out, now I get x squared times that, which is really going to be the mean value. All right, you're going to put, now I've got this times this is an x squared times the mean value squared, which is 25. It's just the mean value of x squared, which we have by definition. You can get it with sigma squared and the mean value squared, right? Y'all with me? Then you're going to have x squared times this term, which is going to be minus 2x cubed x bar, correct, class? And you can keep going down the line, but you can take everything remaining on the other side to get the actual value if you really get jammed up. Now, in the book, he has a formula, and he said this is equal to, what was it, 3 sigma to the fourth plus what?
6 sigma squared.
Plus,
The mean value squared.
and there are tricks when you're doing these. There's all these tricks where if you have x minus a to the nth power, and odd and even, you can expand them, and there are tricks where
It's multiplied.
what's that?
The 6 and
By 6?
Yeah.
This is by 6?
yeah,
Yeah.
and then it's plus
Like that?
plus the mean squared value to the fourth.
Are they adding them? The sigma and the mean?
No, it's 6 sigma squared times
Okay, hold on.
X
Yeah,
bar
that makes
squared.
6 sigma squared times x bar squared?
Yeah.
Is that right?
Yeah.
Is that my phone or yours? It's mine. Sounds like it's everybody, as long as it's not that kind of word. I don't know what it is. Okay, what else?
For me,
I mean, what does this come to?
3793.
That's what I got.
That's what I got as well.
3793, okay. Go ahead. Is there any other
The
part?
36 moment, which is zero. Yeah.
Has to be 0, right?
And
37.
then, the third moment.
And how do we get the third moment using the formula?
Mu q plus 3 mu sigma squared.
That formula, right?
But it would be, since it's 3, this is just 1 times 2, right? And then it's going to be times sigma cubed. And what's it come out to be?
365.
Is that the right answer in the book? Or not?
Not a little
365? Okay.
bit. See you later.
Yeah, I got 365.
The book had, they didn't have to right.
Yeah, it starts with the one value before it starts all the.
All right, never mind. So that's wrong, but I want to do railing next, all right? And this is, what, how many tried the problems in section 5 in the back of the book? Did y'all, they should be straightforward. It's nothing more than applying a simple theory, right? And using, if they want a probability of something being between any two values, just knowing how to use your commutative distribution function. And I can give you tables, but I hate to give you tables if you got a better way to do it. And I don't like tables, unless I absolutely have to. Next problem. Is the Rayleigh distribution function. Now, I think I started talking a little bit about that, but I didn't do anything with it. Has anybody had the Rayleigh distribution function? I want you to just pay attention. This is section, it's not 6, it's section 2-7. 6 is just using, it uses like a y equals x squared operation, like power they have is really I squared r, where I would have if I had a Gaussian distribution, the Rayleigh distribution would be associated with with the power. So here's what happens. The first thing is, this is Rayleigh distribution. F of R is the symbol for it. That's the density function. And if you think about this, here are the assumptions. They assume that you have a variable, y. Shut my phone off. Second, first, lower, landslide, cold front. I'm getting all this news for some reason. Huh?
Lloyd is not fake news.
It's all fake news half the time. I get everything. All right, so what they're saying is there's going to be some y itself, r. This is r, it's like a radial distance, and it's equal to the square root of some random variable x squared plus some random variable y squared. So this is a random variable r, but it's defined as the square root of x squared plus y squared. Furthermore, they're assuming the density function f of x will have the same form as the density function f of y. If they didn't have that distribution, it wouldn't be called a Rayleigh density function. Are you with me on this? So where does this have some application? Think of a target and a bullseye on a target. And call this the x-axis and this the y-axis. And what we're saying is, if I'm shooting an arrow, this is the best way to think about this. I'm shooting an arrow at this target. Based on millions of tries, they found that the density function in the x direction is going to be something that has a 0 mean, and the density function in the y dimension has a 0 mean. So it's assuming f of x, the mean value of x and y is 0, or the average value is dead center. This really does have a lot to do with targeting, trust me on this one. They also assume that the sigma x value, but you need to make sure you put the sub x in, is the same thing as sigma y. So the standard deviation of both x and y is 0. This wouldn't necessarily be true for target shooting if you were far, far away, but close up it definitely is. Just go with me on this one. So if that's the case, then what happens is they form a new variable. If you take a look at this, right, that's f, this is r. So we can get f of r, technically how would you get it? Well, you remember you would have to write the probability. The way you do it is first you say, well, f of r of the random variable r is the same thing, and then it would be a double interval, if you think about this, of x and y, right, the limits, would be a circular limit. This is what I don't like. He doesn't even do the proof. If you think about this, if I say a random variable r here, that's going to have a circular cutout right there, right? So that means if I give you a value for, since I'll just do it this way, I know that r squared is equal to x squared plus y squared. So if I have r and I want to know the value of x, it would be r squared, of the limits of x minus y squared plus or minus square root would be the limits on x. So when you did the double integration, you would have from minus this value to plus this value, then you would have a dy integration. Now, part of this is in the next chapter, so it doesn't make sense to talk about it now. But when we get to the next chapter, I'll do this integration for you. Trust me on this one. Here's what happens. The density function fr of r, and this is in that book, will be shown to be r over, and this is, make sure you put down sigma x here. It's real important to understand that standard deviation has to do with the x and the y variance, not the variance of the actual r value. Maybe I'll put calculator. Times exp, and this will be to the minus r squared over 2, and this will be sigma of x squared. So it's not the standard deviation associated, or the variance associated with r. And in the book, let me just see what this is in section 6. No, let me check. Or section 7, pardon me. It's section 7. So if you look on page 80 in those PDFs, he's going to show you this distribution function, or this probability density function, 2-31. Now the real thing you care about is 2-12. This is the actual cumulative distribution function. So if you take this and integrate it, I'm just going to tell you, the integration on this is not hard. This should be a capital R. When you integrate this dr, here's what actually you get. You find that f of r is equal to the integral. It has to start at 0. This has no negative possible values. Of 0 to r of this function, which is r over sigma of x squared. He does not put the sigma of x. It's implied it's x. That's the reason I'm warning you guys. Sigma x squared exp of minus the mean value. It's really just going to be r squared over 2 sigma x squared dr. And here's the kicker. This f of r, the cumulative distribution function, you could do this. It's not a bad integral, but I'm running out of time. And he'll show this is just equal to 1 minus exp of minus r squared over 2 sigma squared. And this is sigma x. And he should have that. You have your PDFs open, some of you. Which one is that? That's 2-32. If you could write that down. He uses a small r, I'm using a big R. Now, if you look at this for a second, just for a second, there's 2 things I'm going to tell you. One is, 3 actually. When you look at this function, you can see what happens is this. If this is r, this thing starts at a value of 0. This is going to be the cumulative distribution of versus r. And it does this. And asymptotically hits 1. If I look at the probability density function right here of this, and this is important what I'm about to show you, I'm going to try to do it right here. Now if I look at the probability density function versus r, let's put fr of r here, you see it does this. Now what's the value it starts at? when R is 0, right? I got a 0, right? Times some junk. What is 0 times anything? It is 0. It starts at 0, and it comes up, hits a peak, it does this. So this is my f of R, right? Now, the mean value of R, this is real important, the mean value of the Rayleigh random variable. When I take this density function, I multiply it by R, I get an R squared, and then I do that integration, all right? But the mean value, you'll have it there, is actually equal to square root of 2 over pi times sigma x. Let me just make sure I show you this. Oh, I'm sorry, I got it upside down. This is equation, it didn't have a number there. It's pi over 2, pardon me. Pi over 2 times this. So the mean value of R is equal to square root of pi over 2 times, and this should be sigma of x. You see that in there? See? Now, that's the sigma associated with the x or y variation. Now, this is the mean value associated with R. The mean value associated with x or y is 0. Do y'all follow me on this? Mean value of x or y is 0. Then they're going to get something that's going to be sigma of R squared. And that when you take a look at this will be 2 times sigma of x squared. You see that? What equation is that, or where is it? Do you see it in there? It's on the same pages.
Which one is that? F.
Sigma of R squared is 2 sigma x squared. Do you see that?
Page 81.
Page 81? Write this down, please. Because this is where people make mistakes. They will mess these two up. This is sigma x, has to do with x and y variance. This is R. Now, where is the mean value or the most likely value? How would you get it? Where's the most likely value? Well, if we took a derivative of this and set it equal to 0, we would get it, right? The derivative of the density function? And that is R bar by the way. So that's going to be the peak value. And he'll have, I think that's shown, doesn't have it here. What are these variables? Sigma 1, sigma 2, pardon me. For this would be, I don't want to confuse you on this one. If you see these density functions, all right, what's really important just to gather from this, and I'm trying not to confuse you, is that the mean value and the standard deviation of the random variable R is much different than the mean value or standard deviation of X or Y. That's the whole thing. So then, I guess I'm out of time, but in the example problem, he gives this archery problem. Can you give me that example real quick and we'll finish this up? The example. I'll give you the problems in the back, but you're going to see if you understand this, you'll probably get them all.
An amateur marksman shooting.
All right, so we got a bullseye.
An amateur marksman shooting at a target 10 inches in diameter.
All right, so that's the target diameter is 10 inches.
Has an average miss distance from the center of 2 inches.
Now, he's assuming that the average miss distance is R bar, right? That would be the average distance, both X and Y variations count. This is R bar is 2 inches, right? That R bar is equal to what? Square root, and I put it down there somewhere, pi over 2 of sigma, but that's sigma of X. Y'all follow me in this one? So we can get sigma of X, and that's going to be equal to 2 times the square root of 2 over pi. So we can get this back. Keep going.
What is the probability that he will miss the target completely?
All right, so what would that be? Now think about this. This distance is a radial distance. The diameter is 10 inches. That means the outer radius limit is 5 inches. Do you follow me on this, class? Wait a minute. So the probability he misses the target is the probability that R is greater than 5, correct? Now that cumulative distribution function, that right there, it's going, we just evaluate it when R is 5. So help me out with this one where it's gone. So we're going to take f of R, here R equals 5, of that. It's 1 minus exp, and it's minus 5 squared, or 25, over 2, and then it's going to be sigma x squared. Remember, we got sigma x here. And that's going to be equal, if I squared it, 4 times 2 is 8 over pi. So this is 2 times 8 over pi, is multiply this by pi. If you guys get a calculus, the last thing I'm going to do, tell me what that is. So this is 1 minus exp minus 25 times pi over 16. Oh gosh, I can't do that in my head, because I don't know. Oh, I'm sorry, this is the probability he hits the target, my bad. The probability he misses would be 1 minus this, or it's this. This is the probability he misses. Do y'all follow me on this class? I'm sorry I said it that way. So it's going to be, that should be the probability that R is greater than 5.
I got 0.007382.
Is that what he has?
Yeah.
Okay,
Point
0.00782. All right, I'll tell you what, I'm going to put some problems up there, give you problems out of this section. I want to talk about it more, and I'm going to cover Maxwell-Boltzmann on Wednesday. Do me one favor, please. This is not difficult stuff. Learn how to use your calculators correctly. Make sure you do these problems. The Maxwell-Boltzmann distribution is similar to this. The only thing is, instead of an fx, fy, where x and y is mean values, you're going to have another variable. You're going to have x, y, and z. You're going to have fz, because it has to do with the velocity distribution of molecules. And there's an x, y, and z component to every type of velocity in 3D. Go ahead.
How did you get the 5?
Well, it's got to miss the target. The target has a diameter of 5, right? I mean, a diameter of 10, so it's a radius of 5. R is a radial distance. So the probability it misses the target is probability of 1 minus the probability it hits the target. If I take 1 minus this, I get 1 minus 1 is 0. That's a minus sign. It's just exp to the minus 5 squared, or 25, over 2 sigma x squared. But I'm trying to tell you is make sure you put the suffix, the x there, or else, or the y, because you're going to get confused with the standard deviation of R versus the standard deviation of X or Y. Okay? You haven't seen that?